Okay, chapter 4, section 1, extreme value of functions. By extreme values, that means they're either a maximum or minimum. That's singular. The plural is maxima and minima. So which one's which? We're taking with high and low points here. Which one's high, which one's low? Which one? Yes. Maximum is the highest point, and the minimum is the lowest point. And we call those extreme values. We can either have local absolute or global. These two are really the same thing. Absolute and global are really interchangeable. Exactly, yes. Yeah, so this is the highest or lowest point of the entire domain. When we talk about, what do you think local means?
Right, they'll go high, but then at some point they'll go lower, but then they'll go higher.
Exactly,
Another-
like that.
Yeah.
Right. This is a maximum. There's a vertex, but it's not the biggest of the whole thing. But it's, let's say, a big fish in a small pond. That's what that is. So yes, it's the highest of that small interval, which we also call relative. Relative extrema, which means it's the highest or lowest point in a smaller domain, in a subdomain. So it's the highest or lowest point on a subdomain. So you can look at absolute would be the entire United States. Local would be the states. So can you have more than one maxima? You just said it.
Absolute.
You can have a relative and you can have an absolute. Can an absolute be a relative? Minimum, maxima.
That's what is the maximum.
Because you can make it smaller domain. You can say, okay, this one's the maximum of,
You can just cut off the graph.
exactly, exactly, yeah. So,
Doing different maximum.
exactly,
In reality, it's the local.
exactly it. So yeah, the whole picture, or if this is the absolute one, if I do even smaller one, it's still gonna be the absolute, but still now it's called a relative because now I took a smaller domain. Let's look at it in your example sheet. Example 1. The absolute extreme of the following functions on their domain can be seen in the figure. There's a point. Is it an absolute maximum or minimum extrema? Yes, it's a minima. Are there any other points below there? Nope. So it's the absolute minimum. How about this one? Is it a maximum? No. Because there's a graph after it. So it's not an absolute maximum or even a relative because we wouldn't even look at that. There's a point there? Oh, yeah. Is there a minimum there? Yeah, so it's absolute minimum. But this one here, look, it says there's an absolute maximum, but the graph still goes up higher. This one's higher. So that's where it's wrong there. How about this one? Is this the absolute minimum? Because it's open, right? Now, because of that, both sides of that open circle are the minimums, relative minimum, not absolutes. And how about that? Oh, here it is. We're looking, I didn't look at this. For the domain from 0 to 2, now it's a maximum. Even though the graphic's bigger. This one's looking at the domain from open interval to closed. That's an absolute maximum. And both of these are open. You cannot have a maximum or minimum on an open interval, on an open point. It's got to be included to be a maximum or minimum. Why? Because if it says this is an open at point 2, at 2, what's the highest point just short of 2? By 9. Yeah. So you give me as many number 9s, I'll add another 9 behind it. So that's why there's no absolute maximum minimum there. X squared. Y equals X squared. What's my domain there? And it's open interval, right? Do I have any absolute extrema? Yeah, and where is it at? Right. How about this one? I'm giving you the domain on this one. right? Because this one's higher than this one, so. Absolute max. At where? What's the point? Because you put, if you square, you get 25. Do we have a minimum? Zero. There's still a parabola. How about this one? That'd be a max or min. At what point? Very good. We have a minimum? That is the domain. We're not getting to zero.
Well, wait, one? Well, no, not one, because
It's open, right? It's at point zero 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 zero. How about this one?
max on that. Three. Think you do 20%.
Right? What does this graph look like? Right. So the minimum at -2, -8. Because it's included. So you have to make sure that if it's an open or closed. Now, if it's an absolute, do we have any relatives here? Relative extrema on those domains. The answer is always yes, because if you have an absolute, you always, we talked about, if you have an absolute, then you always automatically have a relative at the same point. Simply because you could take a smaller subdomain and that maximum or minimum is going to be still in there. So let's define the extreme value theorem. F of X is a continuous function on some closed interval, AB. So if that's true, then f of x has both an absolute max value m and an absolute min value little m in that domain. So if f is continuous function on A and B, then the function has both an absolute maximum and a minimum value in that domain. Why? See, this is where all the definitions start coming into play. What does continuous function mean? Yeah, there are no discontinuities, no jumps, no breaks, no holes. So with that, then if you have a continuous function, unless it's a horizontal function, then you'll have both an absolute maximum and a minimum, at least one in there. Either you can have them both, or it's closed interval, so you have to have them both. So that is true. You'll have an absolute max and an absolute min in that interval. And then what about that? Where your function has to be between there. Where x1 and x2 are in so let's f of x1 is the minimum, f of x2 is the maximum. Then we'll have that. So three things have to exist for this theorem to work. Must exist for this theorem to work. F of x must be continuous. The interval is closed. Since it's a closed interval, it has to be finite. Can you have an infinite closed interval? Can I go from negative infinity to positive infinity, closed interval? No, exactly, yeah. Any number you give me, I can take another one behind it. So no, it has to be, in order to be a closed interval, it has to be finite. The interval is closed, and well, that's both of them there. So no matter what kind of graphs you have, so the number 3 is the closed interval has to exist and it has to be finite. So if here's A and here's B, the endpoints have to exist, has to be continuous. Because of that, I will have a maximum and a minimum. There's no other way you can do it. Can it look like this? Is it continuous? Yes, I could go from one point to the other without ever lifting my pen. Is it a closed interval? What's the interval? That'd be the range. The interval is always from x1 to some point x1, x2. Is this a function? Why is it not a function? Yep, fails the vertical line test. Can the maximum and minimum be the same point? You know, the maximum endpoints are always the y values. This is a trick. This one kind of is a trick question. Think about it. Can they be the same point? Think of a function. Not this one. This one. Is it a closed interval? Is it a function? Passes the vertical line test. It's continuous. It matches all these guys up here. Is it finite? Yes. So the maximum and minimum can be the same for a horizontal line test, for a horizontal line. Horizontal lines are pretty basic, but that's a thinking question. Okay, I'm gonna give you some questions here. Let's see. Maximum, minimum. Tell me if they have a max and or a min. Sine function. Is it absolute? Oh, I should have said this earlier. Yes. Right. It's periodic. You have multiple relative extrema, positive and negative one, but there's no absolute. Because if it happens more than once, then it's relative.
That why? Does it mean like bounded by those intervals as opposed to this is the maximum?
Right. Because it's not the maximum, it's just bounded by. Has an upper bound and a lower bound.
Now, if you cut out a section of the graph to look between, say, like.
Right. Yeah, that's if we fix the domain.
Yeah.
How about
No max. That's 0.
That's what I'm asking you. So what about the max? Yeah, so that's obvious. It goes up to infinity. How about the other end? Very good. Because it has to be finite and it never goes, and as we get infinitely close to 0, but never touch it. So what do you think? I'm playing over the whole domain. Negative, negative. Right. This is a linear equation. It goes on forever both directions. So that's how we look at local maximum and minimum. Where's my first example? Yeah, sorry. Finding extrema points. Theorem 2 is the first derivative test. Our first derivative theorem for local extreme values or extreme points. If our function f of x is continuous on a closed interval, then it has local max and or min at interior points C of its domain if or when f prime at that point equals 0. If fx continues on a closed interval, that's the domain, is that closed interval. Then it has a local max and min at interior points of that domain, wherever f prime at those points equals 0. Let's see what that means. So here's my function f of x. if the function's continuous and it's in an interval, a domain, I can find a value C at least one value C. So this is C1 and this is C2. As long as the C values are within that domain, that's what it says here. That's what defines an interior point. It has to be within that domain. Or C is contained within that domain. So what I can do is I could find where the slope is equal to 0 by taking the first derivative and set it equal to 0. Take the first derivative, set it equal to 0, solve for x. If the x is within that domain, those are your C values. These C values are what we call critical points. Because they help us find the maxima minima. But there's also another use for critical points. Also help us, we have critical points at undefined points. So where it's equal to 0 or the first derivative is undefined. What is undefined going to look like? Straight up and down. This one is a horizontal line. This tells us where it's 0. But this one, if it's a vertical line, it's no good. Which kind of contradictory because if the slope is undefined, it's not a function. So let's get to example 2. Find the absolute maximum minima absolute maxima and minima values of f of x equals x squared on the closed interval -2, 1. To find the absolute extrema, we got to do a couple things. Find all critical points of the function in the interval. Find all values of f of x at the critical point or points and the endpoints only take the largest and smallest values. Why do we only take the highest and largest and smallest? Largest is going to be your maxima values of f of x. Only take the largest and the smallest values of f of x. So here are our steps. Let's go ahead and solve this one. Find f prime of x. That's going to be 2x. Set equal to 0 and solve. So 0 equals 2x. X, divide both sides by 2, x equals 0. Is that value inside the closed interval? So is 0 inside -2 and 1? Yeah. If yes, then use that value plus the endpoints and plug into f of x. So we have this x value we're going to test. What other x values we're going to test? -2 and 1. So f of 0, f of -2, and f of 1. Remember, f of x equals x squared. So 0 squared is 0, -2 squared is 4, 1 squared is 1. Largest equals the max. Smallest equals the min. So which one's the maximum to min? What's that? Yeah, so the max is 4 at -2. This is the max. The max is 4 at -2. What else? Is 1 Trick question. The min is 0 and it happens at 0. Yeah, so once you get to this point, just look at the answers, 0, 4, and 1. The highest and lowest are your maximum minimum. So far, so good. Ready for example 3? Example 3. Find the absolute max and min values of our function f of x equals 10x times 2 minus ln x on the interval 1 e squared. What's my first step? Find the first derivative. How are we gonna do that? Which method we're gonna use? We can use the product rule, but we have to use the product, even if we distribute, we'll still have to use the product rule. So let's use the product rule. So f of x is 10x. G of x is 2 minus ln x. The derivative of 10x is 10. The derivative of 2 minus ln x. Negative 1 over x. Very good. So f prime is going to be 10 times 2 minus ln x plus 10x times negative 1 over x. Ten 2 minus ln x. Positive is negative. The x's cancel, so we just get 10. We can factor out a 10, leaving us with 2 minus ln x minus 1. Two minus 1 is 1. Okay, so that's my first derivative. Remember, our interval is 1 to 2x squared. What do we do with this thing now, real quick? We find the first derivative. What do we do next? Set it equal to 0. Divide both sides by 10. 1 minus ln x. Move the ln x over. What is that going to equal? What is ln x? What base is this one? It's log base e of x. Because log base e is ln. Log base 10 of x is log. The e pushes the 1 up, so x is equal to e to the first. So that's one of our values. So we have e, x equals e, x equals 1, and x equals e squared. We got to try those three. Because this is the critical point. These are my endpoints. So I have, remember, our original function was 10 times x, 2 minus ln x. 10 times 1, 2 minus ln of 1. 10 e squared, 2 minus ln e squared. What is ln e? 1, because log base e of e is 1. So 2 minus 1 is 1. So this one equals 10e. And remember, e is a constant, 2.81817, blah, 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 something like that. What is ln1? Log base a of a is equal to 1. Log base a of 1 is equal to 0. These are the general rules. So this is log base e of 1. So this one equals 0. 10 times 1 is 10, times 2 is 20. There's also another property that we have to use for the next one. The log, you cannot have an exponent. So if you have an exponent, it comes out in front. If you have an exponent in your equation, it goes out in front. So this 2 goes out in front here. So we have 10e squared, 2 minus 2. ln e is 1. 2 minus 2 is 0. So this one is 0. So do we have a maximum min? 0 is the min. So we have a min at 0, the min 0 at x equals 1. No, at e squared. Yeah. So where's our max? Penny or 20? No, it's 10 because E is 2.8. 2.8 times 10 is 28. So we have a max at that at x equals E. So this is our max. This is our min. Pretty easy. I don't say easy, but doable. Let's do one more. And this is the last example anyway. Example 4. Find the absolute max and min of f of x equals x to the 2/3 on the interval -2, 3. This is a tricky one. So first step, we have to do what? Find the derivative. So it's x to the power 2/3. So bring the exponent down and subtract 1. So we have 2/3. This will be 3/3. So 2 minus 3 is -1/3, which is 2/3 cube root of x. Now we got to set it equal to 0. Here's a question. Can this equation ever be equal to 0? Why not? No. The function can never be equal to 0, not because of that. It's saying, what you're saying is the value x cannot be 0. It's not the solution. But the only way a fraction can equal 0 is if the top is 0. Can 2 ever equal 0? So it doesn't have a solution. In other words, it doesn't have an x-intercept. In this, well, but that's not really x-intercept. But the derivative cannot equal 0 because the top can never be 0. So no critical point. So this is looking at, can the slope ever be 0? The slope can never be 0. Let's look what this graph looks like. This graph. -2, -1, 0, 1, 2, 3. So at -2, -4/3 or +4/3. So we have x is -2 squared makes it +4. So it's a cube root of 4. At -1, we have -1 squared is 1. So it's the cube root of 1 is 1. At 0, it's 0. At 1, it's 1. At 2, it's the cube root of 4. And then at 3, it's the cube root of 9.
0, 0.
This one. Because the points of the graph is this one. Which is interesting. That's right, yes. Remember, 2 conditions for critical points. What were they? Critical points can be at where the first derivative is equal to 0, or where the first derivative is undefined. We forgot about this one. Where is it undefined? At 0. So f prime is undefined at x equals 0. Because now that gives us our 3 points that we need to try. We need to try at -2, we need to try at 0, and we need to try at 3. The function is 2/3. So when x is -2, it's cube root of 4. When x is 0, it's 0. When it's 3, it's the cube root of 9. That's what we did up there. So where's the max, where's the min? Which one? 0 is gonna be min. When x equals 0. How about the max? Which one is bigger? Cube root of 4 or cube root of 9? Yeah. Max when x equals 3. So that's a very important part. You have to remember that the first derivative can equal 0, or it can equal something undefined. All right. That's it for that section.